Perform and complete a full hypothesis test for proportion using the p-value approach. A nurse believes adults who visit the doctor's office for their yearly physical are not getting enough exercise each week. She would like to test the claim that the percent of adults who exercise less than 3 times a week is less than 25%. She decides to complete a hypothesis test at a 5% significance level. She samples 30 adults visiting the doctor's office for their physical and determines the sample percent to be 20%. Work through the testing procedure and interpret the results of the hypothesis test. Now let's recall those steps of the hypothesis test. So first we identify the null and alternative hypothesis. We decide on the significance level. We will then compute the test statistic. Using that, we will find the p-value, and then we will put it all together to interpret the results of the hypothesis test. Let's jump in. First, identifying the null and alternative hypothesis. So we know that this is a left-tailed test because the alternative hypothesis would be if the percent of adults who exercise less than 3 times a week is less than 25%. And it's that last less than 25% that does it. Okay, so when we know, we do know that the null hypothesis is always the equality. So we know that H naught is going to be P equals 0.25 because it's equal. We know the null hypothesis is the equality. And because we're doing a left-tailed test, because it's less than 25%, we know that our alternative hypothesis will be P is less than 0.225. Moving on to our level of significance, we are told that we are at a 5% significance level, so we will use alpha equals 0.05. And now we are on to the test statistic. So remember that we are dealing with a 25% as our expected percentage. Our sample size is 30 and our sample percent is 20%. So that gives us our sample, our p prime here is 0.2, our p naught is 0.25, and then our sample size is 30. So we've got our 3 values that we need. Because we're dealing with proportions, we're going to be using a z test statistic. And so we use our formula using our p prime minus p naught all over p naught times 1 minus, and then we have the square root of all of that with the sample size of n. I find it very, very helpful if you write down your information, so what I did here on the left, and then start with the formula and substitute your values in. It'll help you keep the number straight. It can be very confusing when you're dealing with the 0.2, the 0.25, which one goes where. So making sure that you have everything labeled clearly will help you avoid making those little mistakes. So here, after we plug in our numbers, please make sure to follow the order of operations. Use parentheses if you're punching this all into your calculator at one time, making sure to keep the numerator and denominator separate. After the mathematical computation here, we end up with a test statistic of negative 0.63. We now will use that to find the p-value. Since this is a left-tailed test, the p-value will be the area under the standard normal curve to the left of the test statistic, which as we just found is negative 0.63. So using our standard normal table, we can find that the area to the left of negative 0.63 is 0.264. So thus my p-value is 0.264. That is a pretty high p-value, actually. So now going to interpret those results, we know if the p-value is greater than alpha, we fail to reject. In the opposite way, if the p-value is less than alpha, then we would reject the null hypothesis. In our case, we know the p-value is 0.264 and alpha is 0.05. Very easy to see that the p-value is greater than alpha, and therefore we fail to reject the null hypothesis. So interpreting that, says at the 5% significance level, the data do not provide strong evidence for the nurse to conclude that the percent of adults who exercise less than 3 times a week is less than 25%. We don't have enough data to show that this is true. Thanks.